And on today's portion of 10.5, we're going to focus on solving matrix equations. And we can solve a matrix equation using the inverse of a matrix, which is what we found yesterday. So if we look at this system, it's equivalent to this matrix equation. So look at matrix A. What's in matrix A here? How would we form matrix A? Let's look at our system. Yeah, it's just all the coefficients of the variables, right? You have 1, -2, -4, 2, -3, -6. Okay, and then your second matrix is the X, and that's going to contain all of your variables. And then the matrix B is going to contain all of your constant terms. Now we could verify this with multiplication, because remember when we multiply, we do the row by the column. So if I were to multiply, I'd do 1 times X, which would give me 1X, -2 times Y, -4 times Z, and see how that would equal this first part here? And then it would continue in that pattern, right? You'd have 2 times X, -3 times Y, -6 times Z, -3X, 6Y, 15Z. Okay, so we know that that is accurate. So we're going to let this be the coefficient matrix. X is going to be the variables, B is going to be the constant terms. So the way we'd write this equation is A times X is equal to B. Now we can take the inverse of each side. We can multiply each side by the inverse of A, providing that it exists, and then let's see what happens. So if we are going to multiply each side by the inverse, let's see what that's going to look like. Okay, so we start with AX equals B. If I multiply each side by the inverse, I have to make sure that I keep this on the left side. Okay, so we're going to multiply on the left by A inverse. Now, the reason why I stress that it has to be on the left side is because if we were solving like a regular equation, when we solve a regular equation, if we just had like 4x equals 5, and I wanted to solve that for x, I would just multiply each side by 1/4, and I could write it like this, because 5 times 1/4 is the same thing as 1/4 times 5, right? What's different with the matrices is that when you multiply A times B, it does not equal B times A, which is why we can't have one of the matrices on the left and the other one on the right, okay, like we would with numbers. So that's why I just wanted to stress to you that that has to be on the left. Then from there, we're going to use the associative property. So the associative property says I can multiply in any order that I want. So I'm going to multiply the inverse by A first, and then multiply by X. Right? And that is the associative property. Now think back to yesterday. What happens when we multiply an inverse by its matrix? You get the identity matrix. Do you guys remember that from yesterday? So when you get your identity matrix, I'm just going to call this I sub n, because it's just going to be the general case. So it'll be I sub n times x is equal to A inverse times B. And that's just going to be the property of multiplying inverses. Okay, and And then one more. When I multiply the identity by something, what do you get? That's something, right? So whenever you multiply the identity by x, you're just going to get x. Okay, so x is going to equal A inverse times B. And that's just by the property of the identity matrix. Okay, so what we just showed is that x is going to be equal to the inverse times b. Okay, so we're going to use this today to solve matrix equations. Okay, and I may have mentioned this a few times, but multiplication is not what? Commutative. Okay, so the main thing, like I was telling you before, is when you're multiplying A inverse times B, that's not the same thing as taking B and multiplying by the inverse. Okay, so that's why we have to multiply on the left. So for our first example, we are going to solve the matrix equation given by the system that is above. And for step 1, we're going to find the inverse of matrix A, which is exactly what we did yesterday. So whenever we're finding the inverse, what's the first thing we do? So if we have to find the inverse of this, what am I going to set up?
You want to make the big matrix with, on the right, you're going to want to have the identity.
Yep, exactly. So we want to make this into our big matrix, okay, and on the left side is going to be this matrix, 1, 2, negative 3, negative 2, negative 3, 6, negative 4, negative 6, 15, and then I need the identity. 1, 0, 0, 0, 1, 0, 0, 0, 1. And then remember, your first step is always to get a 1 in the upper left-hand corner. But look how nice this is. It's already done for us. Okay? And remember the matrix that we did yesterday, I told you I wanted to do one that was more difficult. That way you can't just say, oh, you always do the easy ones in class with us. You give us these hard ones. So you're going to see this one, finding the matrix of this is going to be a much nicer process. Okay? So once you have your 1, the next thing you want to get are zeros below it. So once you get the 1, you always want to multiply that row by the opposite. Okay, so that's a good strategy to use because you can always go back to it. So the opposite of 2 would be negative 2. So I can multiply row 1 by negative 2. I can put my negative 2 in there. Negative 2 times row 1, and then I'm going to add that to row 2, and that's going to be my new row 2. And then remember how we talked about how we can do the 2 steps in 1? So if you're trying to get 2 zeros at the same time, let's just do those 2 steps together. So the opposite of negative 3 is 3. I'm going to multiply that by row 1, add it to row 3, and that's my new row 3. Okay, and if you want to work ahead of me at this point, that's perfectly fine. And then if you feel like you need some more practice, we can do this part together. So my first row is going to stay the same, so I'm just going to write that in there. Now, when I'm going through this, I'm going to talk out loud with what I'm saying in my head. So when you're doing this, you should be having that inner talk with yourself. Okay, so I'm doing negative 2 times 1, and then I'm going to add that to 2, which is 0. I'm going to multiply by negative 2, which is 4. 4 plus negative 3 is going to be what? 4 plus negative 3? 1. You guys doing this with me? Okay, and then negative 2 times negative 4 is 8. 8 plus negative 6 is going to be 2. Negative 2 plus 0 is negative 2. 0 plus 1 is 1. 0 plus 0 is 0. Okay, and now let's do the last row. So this would be 3 plus negative 3, which will give me 0. This would be negative 6 plus 6, which is 0. 3 times negative 4 is negative 12. Negative 12 plus 15 is 3. 3 plus 0 is 3. 0 plus 0 is 0. 0 plus 1 is 1. Okay, so I'm talking myself through that as I'm doing it. So now that I have the 1 here, look what also happened. See how I got the 0 underneath? So now all I need is what? The 0 on top, the 0 above it. So I want to make this a 0. Okay, so all you have to do is multiply this row by the opposite. So once you get that, once you have that leading 1 there, you always want to multiply that row by the opposite. Okay, so I'm going to put my arrow here, but then I'm going to do my matrix below. So I can multiply this row by, really I have to multiply by positive 2, right? Because that's the opposite. So 2 times row 2. I'm going to add that to row 1, and that's going to be my new row 1. So my other rows are going to stay the same. So 0, 0, 1, 0, 2, 3. And it is helpful to keep these in the same column. Try not to smush them together, else it'll be hard when you're trying to do this step. So I'm going to do 2 times row 2. So 2 times 0 is 0. 0 plus 1 is 1. 2 times 1 is 2. 2 plus negative 2 is 0. 2 times 2 is 4. 4 plus negative 4 is 0. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. 2 times 1 is 2. 2 plus 0 is 2. 2 times 0 is 0. 0 plus 0 is 0. Okay, so now I have 1, 0, 0, 0, 1, 0. So now in this row, I have to get my what? I have to get my leading 1, right? Okay, so Ryan, what can I do to make this a 1?
You could multiply R2 by negative 1, and that would get you a negative 1 and then 0.
If you multiply this by negative 1, the only problem is this would, yeah. So a good thing to do when you're trying to get the 1 is multiply by the reciprocal.
Okay.
So the reciprocal of 3 would be what? 1/3. So I can just multiply row 3 by 1/3. And that is going to give us a couple fractions, but it's also going to give us a couple whole numbers too. So this one's not too bad. Okay, and then my first 2 rows are going to stay the same, so I'm just going to keep them. So this would be 0, 0, 1. 1/3 times 3 is 1 again. 0 times anything is 0, and then 1 times 1/3 is 1/3. Okay, and then, Jory, after I get this 1, what's the next thing I want to do? So after we got this 1, we got the 2 zeros below it, right?
Yeah.
Then we get this 1, we get a 0 above and below it. So after we get this 1, we have to get,
0.
yep, zeros above it. And look, this 0 is already there, so then all we have to do is make this one a 0. So that's pretty nice. And the way that you're going to get it to be a 0 is multiply the row you just changed by the opposite. So see how I just changed row 3? Okay, so now what I'm going to do is I'm going to multiply by the opposite. So what's the opposite of 2? Negative 2. So I'm just going to multiply row 3 by negative 2. I'm going to add that to row 2, and that will be my new row 2. said
-2 or 3.
R2. Oh, yeah, no, that does not matter. No. Okay, and then your row 1 is going to be the same, so I'm going to write that first. So 1, 0, 0, negative 3, 2, 0. And your last row is going to be the same, so 0, 0, 1, 1, 0, 1 third. Okay, so this is going to be negative 2 times 0, so 0 plus 0 is 0. 0 plus 1 would be 1. Negative 2 plus 2 is 0. This is going to be negative 2 plus negative 2, which will be negative 4. This will be 0 plus 1. Negative 2 times 1 third is negative 2 thirds. And then I just add that to 0, so I'd keep it. Right? Now we can see on this side you have the identity, right? Which means this side is now A inverse. So let's write out what our A inverse is. Okay, so the inverse of A is going to be negative 3, negative 4, 1, and then 2, 1, 0, 0, negative 2 thirds, 1 third. Okay, how'd that go? Not too bad? Alright, so then we're going to go to step 2. So for step 2, now what we're going to do is multiply A inverse by B. Okay, so when we multiply A inverse by B, I'm going to take my A inverse from step 1, which I just found in step 1. Okay, so that was negative 3, negative 4, 1, 2, 1, 0, 0, negative 2 thirds, 1 third. And then I have to multiply that by B. Okay, so this was my A inverse. So I'm just going to go back to the front and show you where you can find B. Okay, so these were our matrices, A, X, B. So B is this matrix, your 7, 5, 0. So we are going to multiply that by 7, 5, 0. So remember earlier this week we learned how to multiply two matrices together. Do we remember how? Yes, the row by the column. Good. Okay, so the first thing we want to do is make sure they're compatible. So this is a 3 by 3. This is a 3 by 1. So, yep, those are going to match. And then what's our result going to be? A 3 by 1 matrix. Okay, so that means my final answer is going to be in a 3 by 1. Alright, so then let's start multiplying. So I'm going to do the first row times the first column. Okay, so remember that you multiply the first element by the first element. So negative 3 times 7 is negative 21. And then 2 times 5 is 10. And then your last element is just 0. So negative 21 plus 10 is negative 11. Now that's the only column we have. So now we have to go to the second row and do the first column. So negative 4 times 7 is what will be multiplied. 1 times 5. And then this is multiplied by 0. So negative 28 plus 5 is what? Negative 23. And then I go to the third row. So 1 times 7 is 7. This is 0 times 5, which is 0. 1/3 times 0, which is 0. So then I get 7. So my solution for x is going to be that x is equal to negative 11, negative 23, 7. Okay, now this means the same thing as the point negative 11, negative 23, 7. So this is just another way that you can solve a system of equations by using your matrix equation and the inverse. So what we just proved is that this matrix equation can be solved using the following method. Okay, and that method is going to result in the solution being formed from multiplying the inverse of A times B. Okay, so remember that multiplication is not commutative. So when you go to multiply, you have to multiply A inverse times B, not B times A inverse. Okay, so that's important the way that they are set up. For example 2, we're going to do the same thing except you can use your calculator. So I'm going to show you how you can use your calculator to solve. So the first thing we're going to do is write the system of equations as a matrix equation. Okay, so we're going to write the system of equations as a matrix equation. So a matrix equation is exactly what we had here. Okay, so you're going to have your matrix A, X, and then B. So can you guys try to set that up for part A? Alright, let's see how we did. So notice what variable is missing from the first equation. An x. So then what do we put in for x? 0. Okay, so the coefficients of the x's are 0, 3, 1. The coefficient of the y's, negative 2, 1, negative 2. And then the coefficient for the z's is 2, 3, 3. Okay, and then that's going to be multiplied by x, y, z. And then that's going to be equal to the constants 12, negative 2, 8. Okay, so remember your setup is A times X is equal to B. So we're going to solve the system by using the matrix equation, and I said that you could use your calculator to solve, but we're still going to write out what our equation is. So the equation that we're using to solve is that x equals A inverse times B. So the first thing we're going to do is use our calculator to find the inverse of A. Alright, so then I'm going to go to matrix, which is right here. So I'm going to go to second matrix. Okay, and you might already have some in there from before. If you don't, you're just going to go over to edit and then select enter. So now I can put in my matrix. So I'm going to put in my matrix A, which is a 3 by 3 matrix. Okay, so here's our matrix A right here. Okay, so I'm going to type in 0, enter, negative 2. That was not negative 2. Negative 2. And then 2. So as you press enter, it's going to keep going to the right. And apparently I did a 3 by 30, which is not what I want. Okay, so the first row is 0, negative 2, 2. The second row is 3, 1, 3. And then the last row is 1, negative 2, 3. Okay, so now that I have matrix A entered, I have to quit. Okay, I have to go to my blank screen. So I'm going to go to second quit. So I have a blank screen that I can put my matrix on. So go to second matrix. And then I'm going to select A. So just press enter. And then this is my inverse button, the one that you push to get to matrix. So see how that says A inverse? And then enter. And that is going to be your inverse for A. Okay, so then what we're going to do is we're just going to write out what our inverse is. Okay, and that's what I mean by still write out your equation. So still write out what your inverse is. So it'll be negative 4.5, negative 1, 4, and then 3, 1, negative 3, and then 3.5, 1, negative 3. Okay, and then I'm going to multiply that by matrix B. So matrix B is 12, negative 2, 8. And then I'm going to show you how you can do that one on your calculator. Okay, so now I have to define matrix B. So I'm going to go back into my matrix again. I'm going to arrow over to edit. And then I'm going to go down to B. And B is a 3 by 1 matrix. And I have 12, negative 2, 8. So again, I'm going to have to quit out of that. And because I already have A inverse in there, I can just multiply by matrix B. So I'm going to go back to the matrix and select B. And that's going to give me my final answer. Okay, so then X is negative 20, 10, 16. And remember, you can always plug those back into your equations to make sure that that works. Okay, so this was your solution to the system. Now, I also just want to show you that when you're multiplying, if I were to do B times A inverse, okay, and press enter, this means dimension mismatch. So you can't even multiply those together. Sometimes you might be able to, but it would still not be the same answer. Okay, so if I do A inverse times B, that's what's going to give you your correct solution. Because multiplication is not what? Commutative. Good. Okay, now I gave you some special directions here for this day. So these are the problems that you're doing by hand. The 1921 and then the 30 and 32. It says this in the book as well, but I put it here too. It says use inverse from your homework problems 18, 21, 23 as it directs in the textbook. So your homework from yesterday, because we did 10.5 in 2 days, was this. So you need to do this part first, because when you start to do these by hand, you aren't going to have to find the same inverse twice. Okay, so you've already found the inverse in these problems here and doing these problems here. Okay, and then you can use those to do these homework problems. Okay, there might be one of them that you have to find in case it's 23. I don't think I put 23 on there. And then for 33 and 34, you can use your calculator. All right, so I'm giving you the rest of the time today to start this. And then tomorrow, I'm also gonna have you working on this in class. Okay? And then we're gonna start reviewing for our chapter 10 test, which is next Thursday. Hey, do you guys have questions for me, what you're supposed to be working on?
Wait, so we're doing, is homework